Many photographers want to use parabolic reflectors, and of course many photographers try to find more economic solutions compared to some of the top brands. But how do the more budget options actually perform compared to the top brands? In this video I do a direct comparison and I do a hack to try and make a cheap modifier work more effectively. In recent months, I've posted a popular video on why I love parabolic reflectors, providing a breakdown of how they work and why they are effective. I followed that video with another video about parabolic softboxes and why they are not any more effective when compared to conventional softboxes. Parabolic reflectors, though, are completely different to softboxes and have a different purpose. They are used mostly in beauty and fashion photography for their ability to collimate light and focus it to an area. Or they can be used in a defocus position to provide a ring of light of multiple hard lights with an angle of incidence on the subject that creates a unique and attractive three-dimensionality. Unfortunately, parabolic reflectors can be very expensive, so I wanted to find out how effective a budget one could be when compared to a top brand, or if I could come up with a hack that could be used to make a cheap one more effective. Let's take a look. So I'm going to do some comparison tests on a budget Para of the same dimensions as the Broncolor Para 133. We're also going to test them on a model, test the spread of light on the wall, see what it looks like. But I'm also going to try and reverse hack engineer this parabolic softbox. You might remember the video where I said recently that these things are a waste of time compared to a normal softbox, given that they don't provide anything else other than extra weight and size. But I do think I might be able to take the focusing rod from that budget Para, fit it into here, and maybe at least make a usable parabolic reflector rather than a softbox from this one. In this clip, you can see how each modifier collimates the light when we direct the light onto a plain white wall. Fall-off and central strength differences are apparent with each modifier. In this clip, you can see the internal reflections of each modifier, from the defocus position to the mid and hard position, and back again. Correct parabolic design should reveal multiple specular highlights in the hard, mid, and soft positions. Okay, so we're ready to do our tests with our model Brittany. And you can see I've just got a tri-reflector below here just to bounce a little bit of fill light from the main Para lighting back under the jawline. That's normally how you'd use these lights, or with a slight fill light. So we've put that in. We're going to start with the Para 133 in the soft position. Well, I call it soft, but it's the defocus position, which is the most flattering really position for the Para 133. And then we'll shoot it in the mid and the harder light position, and then we'll switch over to the other Paras in exactly the same position. I'm using a 100mm lens on a Hasselblad 100 megapixel medium format camera, and you can see the camera is directly below the edge of the Para. That other Para is the same size as this one, but when we come to use the parabolic softbox that we've done a hack on, it's a bit bigger, so we'll have to push it back a little bit further. But everything is going to be shot consistently, so we can compare the results identically. So that was the mid focus point. Now I'm going to pull it into the hardest focus point. So it's in exactly the same position in relation to the camera, and it's in its softest defocused position. Now we'll move it into the mid focus position. Okay, and finally into the harder light position. Right, good. So that's the budget Para compared to the Broncolor Para 133. We'll look at the results shortly, but before we do, we're going to try and hack that parabolic softbox and turn it into an actual parabolic reflector and see if we can get anything useful out of it. So this was that waste of time parabolic softbox, but because it has a nice shiny silver reflective material, I think we can take the central focusing rod from that one and put it in this, and we may be able to hack this into a decent parabolic reflector. So straight off, the problem is that that rod looks too short for this Para. It will have some effect, but ideally for a Para this size, that rod would need to be longer. We can hack it by probably putting a light on a giraffe boom, which we might try afterwards. Now this is a lot bigger. This is about 150 centimetre, so you'd be more accurate doing a comparison to the Para 177. The other problem with it is with the construction. You can see it's not really circular. It's gone a bit of an egg shape, unfortunately. Now that was very odd. In the mid position, which should give you a harder, brighter, more focused light, in this thing, the light actually got softer and less bright. Great, that's all of them tested, so we'll now take a look at the results. Thanks very much, Britt. So let's take a look at the results. I'm going to put them side by side, and then we can compare like for like, as well as zoom in on them. But first, let's just run through each shot full screen. So this is the Broncolor Para 133 in the soft position. Here it is in the mid position, and then in its hard position. This is the Pixapro Parabolic Reflector in its soft position, its mid position, and the hard position. And this was a budget deep parabolic softbox that I purchased on Amazon, but I've hacked it and used the central focusing rod from the Pixapro modifier. This is it in the soft position, the mid position, and the hard position. Okay, let's do some side-by-sides and discuss them. Let's use the most expensive, the Broncolor Para 133, on the left in the soft position and compare it to the others. So here on the right is the Pixapro in its soft position. And for me, it's not doing what a well-designed parabolic reflector should do. And that is forming a ring of light on the periphery of the reflector to give you the three-dimensional quality we see from the Broncolor Para 133. The image looks softer, less sculpted, and you can see the more generalized spread of light is affecting the background to a greater degree. Part of the problem, I think, with the Pixapro in its soft position is that it has a more diffused internal reflector, which is scattering the light in all directions and losing the ability to form a harder ring of light on the periphery of the reflector. If we then move the Pixapro in its mid position, it does harden up the light slightly, but it still doesn't achieve the same type of three-dimensionality or sculpting. If we move it into its hard position, it gets better, but it still doesn't provide the quality of the Broncolor Para 133, even with that in its soft position. And finally, let's run through them equally. So both in the soft position, both in their mid position, and both in their hard position. Okay, let's go back to the Broncolor Para 133 in its soft position and bring in my hacked version of what was a useless parabolic softbox now converted into a parabolic reflector. Here, the hacked one in the soft position is actually quite effective. For me, it's better than the Pixapro, but it's still somewhat lacking in the quality of sculpting. Now it's in mid position, it does something very strange and actually becomes softer. And this is likely because it's not actually conforming to a true parabolic shape, meaning that the light is not collimating, but instead bouncing out more like a standard silver umbrella. This is also evident from the background exposure level. Here, in the hard position, it improves but still suffers an imbalance in the spread of light. And finally, let's run through them equally. So both in the soft position, both in their mid position, and both in their hard position. So in conclusion, the most expensive modifier provides the higher quality of light. The explanation as to why comes down to the physics. The internal reflection material is perfect for its size, it provides the right level of specularity, and has a very accurate parabolic shape to ensure the light is collimating correctly. The Pixapro in my mind is most useful in its hard position, but otherwise it seems to provide a look not much different to an Octabox softbox, and in a future video we'll show the results of it compared to the Octabox. And finally, my hack only really worked in its soft position, which did provide a sculpting quality of light that I felt was better than the Pixapro in all positions. But the hack was let down by the quality of construction and its inability to keep its shape. Now, of course, these are just a couple of alternative brands tested, and there is a big price difference between them, which seems to be reflected in the quality of the results and the build quality of the products. But if any other brands wanted to send us their parabolic reflectors for a comparison test, then please let us know. Well, I hope you found this video useful, and thanks very much for watching.